Okay. Yeah, really, the only stuff that we did yesterday that you won't exactly need for right now is the concavity and the points of inflection. Everything else you pretty much. Huh?
That's the part I understood.
Well, then 5.3 will be easier for you.
I understood the concavity and stuff.
All right, you are going to need your books out because these first problems have pictures with them. So page 198. So these say to find the extreme values and where they occur. So basically, if there's a min or a max and what it is, and there could be multiple, potentially. Let's see. Oh, wait. I need a different book. This one has the answers in it.
Oh.
I was like, wait a second. The second I put it up there, it just literally has answers.
Yes. Taking mine too.
Josh, Ethan asked if you can get his too.
Oh, yeah.
Oh my gosh.
Should have sent Christian. Christian's faster.
I'll go get it.
He was
Wow,
like,
that was.
Wow, that was so fast, Christian.
he was like invincible.
Oh.
That
Christian, that was so
Oh my
fast. Good job.
Did I doubt I was getting it or something?
No,
was, we did.
no, I was like, yesterday Christian was so fast when he went to get the book. I was like, we should have sent Christian because he was like lightning speed,
Oh.
like just being funny, and then he was like, okay, I got it.
It was lightning speed. It was pretty good.
Literally.
Yeah.
All right.
Yeah, we're in the room.
Find the extreme values and where they occur. So we're talking about max and mins here. So we're looking at number 2. So we're looking, it's where there are closed circles, okay? So if it's open, like up here, that can't be a max because it never actually gets there. This point that's like a point by itself, I thought you ripped a piece of paper. It's like a point by itself, also can't be a max or a min because it's just a point, okay? So our min, okay, because it is increasing after that, so our min is at -1, 0. Then the max, so that's another open circle there. Going up, we have a closed circle here at 1, 0, so a max at 1, 0.
So you said it can't be the open circles?
Correct. Because it's like a parentheses, like it doesn't actually get there.
Can't be a point by itself. Just
Yeah. All right. 4. Now I'm gonna tell you this one has multiple.
okay.
Oh.
Multiple mins and maxes.
Yes. So, any guesses for?
So
A
I would
min.
say the min would probably be -3, 0.
-3, -1.
What do you say a 3 and
Min would be. Well, how about
-1,
1, 2?
0,
Uh,
-1.
Nathan, which one did you say?
What do you mean? I said 2.
No, what was the last one you just said? The first one you said was wrong.
1, 2.
As a what?
As not a point, but
Is it a max or a min?
oh. I said that
Where's
for
your 1, 2?
min. Max.
Oh, I see.
So you're saying that 1, 2 is a max.
Yes.
What's the definition of max?
Like a maximum point, like a mountain.
I'm
I'm
gonna
gonna
go
go
with
max
yes.
is a mountain.
I'm gonna go with yes.
Okay.
2 would be a max.
Yes. 1, 2 is a max. Okay, Josh, what was the other one you said?
Did I?
You
Yeah,
did.
you said 0, -1.
I did say 0, -1 as a min.
Okay, 0, -1 is a min. Okay, Ethan, you just said the numbers backwards.
You said there's more than 1?
Sorry.
There are 2 of each.
So would 2, 0 be a min?
Yes,
And
2,
then
0 is a min.
Yes.
Because it's going
Because it's come down
It's the down
and it
of that
stopped.
line.
It's the down of that line.
Well, look, when we were in anatomy, we were supposed to say lower lip because it was like the mouth muscles, and he said
I said
downer
the downer
lip.
lip.
Love
Down.
that.
The downer. I was like,
So what about the
point?
point -3, 0?
What about it?
Yeah, what about it?
What is it?
It's a neither.
The book.
It's
a
a
max.
neither.
It's a max.
Because it's the up of that one.
Because from here, it starts high and goes low. When we get to a low, we start low and go high.
So that's a max.
We get to a high, a max. We start high and go low. And we get here to
okay,
a min.
I see. I think I understand now.
Okay, good. I was getting a little worried.
I understand.
Like the up and down.
I was like, I'm
I
not
actually
sure.
understand.
Well, I was just kind of
I was
confused,
just-
like how there could be multiple.
I understand.
So remember, like locals, we can have multiple. But the global, absolutely can only have one.
I understand. I just didn't know how
So
to-
you can have, like, out of those, we can have one that's absolute.
Okay.
Like the
max.
absolute oh, okay.
Like,
So
the absolute max. Like, the only, like, the
Like
the
the-
most
yeah,
max.
okay,
The
I
max
understand
is
that
the
part. I understand
But
that
we
part.
are not in that
That's
section
just
yet.
the max.
That section is actually 5.3.
Maxius is a max.
The max is the max. Wait.
The max.
The max is of the max.
Okay.
Yeah.
The next one say, you still need your books. Identify each x value at which any absolute extreme
Oh,
values
got it.
occur.
Boys.
Explain how your answer is consistent with the extreme value theorem.
Ew. Explain.
What's
right.
It has to be a point, doesn't it?
So this is where we're looking for the most max and the most min.
Okay.
Now, before you say anything, I'm going to remind you what the extreme value theorem
Let's
says.
do.
Okay? Where did it go? It's over here. If f is continuous on a closed interval, so no gaps, holes, none of that, then f has both a max value and a min value on the interval.
If what?
Okay.
If
If
what
there's
has what?
So if there's a closed interval,
There's a closed interval.
then there is a max and a min value on that interval.
Okay.
And it's got to be continuous.
Okay.
That's the other factor.
So you have to determine first that it's continuous.
Yes.
It looks.
So that's just saying that the extreme value theorem applies. There can still be a max and a min, but the extreme value theorem does not apply.
Oh.
I think it does apply. Yeah.
So 6,
There's no gaps.
we've got
Ew.
2 endpoints that are filled,
Mm-hmm.
so that means included. And there's no gaps, holes, anything like that in between. Okay? So that means that it's continuous. Right? So we're looking for the max and the min. That's the most max and the most min.
The most max would be C, and then the min
Would be B.
Yep. So we would say the max occurs at the max is at x equals c. Min is at x equals b. And then we would say something like, just because of what it's asking, extreme value theorem, which I usually write as EVT, applies. So both max and min exist.
But max and min can exist
There can be a max and a min without that, because you could have a function that's not continuous. All right, 8. So I've got
I don't think the theorem applies.
open circle. I've got another hole in the middle and another open circle. So what does that tell us?
The theorem
No.
does not apply.
Why?
Because
That's
it's
not
not
continuous.
continuous.
It's not continuous, and
It's not
so,
starting.
and we don't have endpoints, so there's no max and min. Okay, because those endpoints are holes.
Oh.
It just doesn't even start.
So we would
It's a
say
little darker hole.
no max or
It's
min.
not connected.
It doesn't fill anything.
It has to actually be like into the function, because otherwise it's just a point. That would be a removable discontinuity, as a refresher. No max, no min. And we would say EVT does not apply. Because function is not continuous or defined on a closed interval. Because it could have theoretically been continuous but still not defined because the endpoints had holes. Technically.
So if there was no hole in the middle, it would be like continuous but not defined? Or like how would it be continuous but not defined?
Yeah, if there wasn't a hole in the middle.
Oh, okay. Oh, so 7.
Yeah.
Okay.
Let's see. 10. What do you think about this one?
So it's continuous, but it's not on a closed interval. Because
One side of it is closed.
one side is closed, one side is not closed.
So what does that mean?
So could C be like a closed interval?
Let's see that.
Let's see it now.
So okay, so this is where where that applies. So since it's like right above it, you can fill in for it.
No.
No, it's not
Okay.
attached, right?
It's not continuous.
It's not continuous.
It is not continuous. However,
Wait, how is it not continuous? Because it jumps.
well, there's a cusp for one,
Oh, I forgot cusp.
which remember is one kind of discontinuity, but because there's a point above, it's not continuous. The reason I said the other one, because it would be the same thing in 8. If we said that that point could fill in, that would have been continuous. But the point can't fill in, so it's not continuous.
Why can't it fill in again?
Because it's it's a different value,
Oh.
basically. So this one, the extreme value theorem doesn't apply because it's not continuous, but it has a max and a min. So what would that be?
Max of A. Or no.
Max of X.
And then a min of C.
Yep, max is at x equals a, min is at x equals c. It's not continuous, so EVT doesn't apply.
Why would the max not be x equals b?
Because it's not the highest point.
Is it because of the dot?
Yeah.
And yeah, I know you were thinking that, Josh, because the other ones are like at the same.
It just b looks higher than a. Is that not how you determine it?
You do it by the dot.
Well,
Not just the dot, but like
B
the
is
highest.
higher than A, or B is not higher than A.
'Cause-
The point from A is higher. The point that's removed is
Not the-
higher.
Oh.
So we have to look at that for max and min. For absolute. To look at that. Fumble. Go to page 194 and look at example 3 for a second before we do a problem. The next problem says use analytic methods to find the extreme values of the function on the interval where they occur. Identify any critical points that are not stationary points. So critical point is, obviously they have the definition up there, is a point in the interior of the domain of a function f at which f prime is equal to 0 or f prime does not exist. But a stationary point, everything about the definition is the same except for it does not have the derivative does not exist part. Okay. A stationary point can be a minimum, maximum, or an inflection point. Notice that critical points and stationary points of a function are not necessarily the same. So, example 3, it says find the absolute max and min values of f of x equals x to the 2/3 on the interval -2 to 3. Okay, so those are the endpoints that are given to us. Okay. So solve analytically. So remember, the first thing we do is we take the derivative. So we evaluate, or we're going to eventually evaluate at the critical points and the endpoints, but we have to take the first derivative, get that value. We see if there are any zeros. Okay. In this particular problem, there is not, because we have the square root of x on the bottom being multiplied by something. So if we put in 0 for x, then it's undefined, and there's no other way that that function is going to be equal to 0. So there is, let's see, there's no zeros, but it's undefined at 0. So where it does not exist would be a critical point, right? So does not exist is where it's undefined. So that's why they're putting in f of 0 is equal to 0. Then they put in f of -2, and notice these are all going into the original equation where they're checking them, not the derivative equation. The derivative is just helping us find critical points. So they're checking it at the endpoints that were given to us of -2 and 3, the critical value where it was undefined. And then it says from there we can see that the absolute max is at the cube root of 9, because that's the biggest value. And we say where it occurs, and then there's an absolute min at 0 because that's the lowest value, and it occurs at, we call that an interior point, x equals 0. So it's either an endpoint or an interior point are the two options for that. Sometimes we're not quite as specific. It just depends on the given situation. So now we're going to jump and actually look at some problems. I just wanted you to kind of see that to hopefully give a little bit of a, somebody at the door,
Yeah, let him show up.
figures.
Let me see this. I feel like you need a bigger
Yeah, I do.
desk space.
Or just less stuff on my desk. That also would be sufficient. But, you know, it's fine. Okay. So 12. G of x is equal to e to the -x And it's the interval -1 less than or equal to x less than or equal to 1. So remember, that's the same thing as -1 to 1, the way that it was given to you in the problem we looked at a minute ago, the example problem. Just a different way for them to provide information. So we're going to take the derivative of the function. I know it's been a hot minute.
I know it.
What is the derivative?
E to the negative x.
Almost.
Oh wait.
E to the x equals e to the x.
This is technically a chain rule.
Oh, is it? Oh,
What's the derivative of -x?
Like
What?
Negative one.
-1. So we put a negative out front. Now, it has a negative exponent, so we could rewrite it as -1 over e to the x. May or may not be helpful, but we can rewrite it that way. So are there any values that would make this 0 or undefined?
If the exponent is 0.
What is anything raised to the 0? 1. So is that going to be a problem?
So there's
There may not be. There doesn't have to be a critical point. So we're just going to check the endpoints. Because based on that, there's nothing that we need to be worried about inside. No interior points that we care about. So we check the original equation. Now, I'm going to be obnoxious about it because there are going to be times where you're checking the first derivative of things, times you're taking the second derivative. But when we're doing this for extreme values, we're looking at the original. So g of -1. So I have e to the -1. So e to the 1 is just e. Then I'm going to check the other endpoint. So g of 1, which is going to be e to the -1, which is
E over 1.
negative
1 over e.
1 over
All right, so which one is bigger?
the top one.
E.
So there is a max at x equals 1.
Is with the max at 1 or negative 1? Or
Sorry, -1, yes. Then a min. I was looking at this number here when I wrote that, and then I was like, yeah, something's not right. Min at x equals 1. There we go. All right, this next one is going to be a little different. Where is, let's see if there's an example like this one before we do it. Maybe not. Guess not. We're just going to roll with it.
He's scared of the potato.
what potato?
On the box.
And it really has like legs and arms and looks like.
What
So
potato?
does the cabbage.
Did y'all not make spud babies in 7th grade?
I made a spud
We
baby.
did.
What's a spud baby?
It's a potato. We made the spud babies.
It was like you did like the genetic stuff and then you made a potato with those genetic modifications.
Yes, we did, because William left it in his locker and it grew other potatoes.
But what potato are you talking about in the first place?
That was
On the box down there.
If your desk wasn't like to the door, you might be able to see it.
I think the coleslaw's scarier.
The coleslaw is scarier.
No, it's
The
not.
crab's just normal.
Bro's just a cabbage.
Bro's just a potato.
I thought that was a pig.
I thought.
That's a crab.
Is that
No, it
created
wasn't
that?
less. It was
Yeah.
Oh.
Not that it really matters, but yes.
There's gonna be fancy.
Wow.
What was that?
Bless you.
That was a sneeze.
I mean,
Was the first one not a sneeze?
It was a cough.
No,
Well,
was
you did-
it?
Well, it sounded like it was gonna be a sneeze. You were like,
Oh.
and then you coughed.
Huh.
we should use one of them underrated letters that never gets used in math.
B. Wait, no, that gets used.
W. W of X.
F of oh, wait, never
F.
mind.
Yeah, F.
Have
I
you
said
ever?
F
F
of
is
X.
underrated.
Have you ever realized
I
just
think
like how much
X.
effort it is to say the letter W?
W. Oh, it's like
W.
double. It's like
Double.
syllables.
I know, it takes the most
It's
amount
like
of effort.
syllables.
Just say W. W.
Like F.
You know, it
Just
takes
be like
more,
dub.
You know, it takes more
W.
effort to say www than World Wide Web.
World Wide Web. www. Oh my gosh.
Oh, that's also the same thing for like
There's more
gunshot.
syllables.
Gunshot wound is abbreviated.
If you
to
start
DSW,
saying
it's more
go to
syllables.
World Wide Web dot blah blah blah, you're gone.
Yeah.
Yeah, that's what I'm saying.
All right. Now, are we gonna have endpoints on this one?
Oh, that's what WWW
No,
stands
wait.
for.
Oh my goodness.
All right. Are there endpoints on this problem?
No.
No.
No. So that means I only have one other thing that I might need to do.
Critical.
Critical point. So I'm gonna take the derivative.
Serenaded you.
Sarah, that's
Yeah, sirens do that too. They don't sound good.
What would the derivative of this be?
Mermaid thing?
It would be
You gotta like.
because it's like a double chain. No,
so
It is a chain rule.
it is
I
a
know.
chain.
I don't know
So
about
e
double.
to the negative x squared.
Okay, that's part of it.
Yeah,
The easy part.
that is the easy part. Times.
Sounded like a muppet when you said.
I was thinking that.
Like Kermit.
Patrick Mahomes.
Times negative 2x.
Negative 2x e to the negative x squared. So now I'm going to set this equal to 0. So that means the negative 2 would go away and I'd be left with x e to the negative x squared. So what is the only way that can be equal to 0?
If
Because there's no way for it to be undefined.
If
x
the-
is 0.
If x is 0. So x equals 0 would be the only 0.
So that's.
the critical
Is
point.
that the correct one?
That's a critical point.
I was a little confused.
Yep, because we don't have any, there's no endpoints on this one because it just goes to infinity. Now, they could, obviously, an exponential function just goes on forever, but they could have capped it and said we're only going to look at this portion of it, and then we would have had endpoints, but they didn't give us any. So now, into what?
What?
Where am I plugging this?
The original.
The original. So k of 0. So e to the, well, I was going to say to the negative 0, but that just doesn't sound right. So e to the 0 is equal to
1.
1. Now, there's a small problem.
Of course.
At least it's.
We only have one value, right?
Yeah.
So how do we know if it's a max or a min?
We don't.
You don't know.
We don't currently.
Oh, I thought we didn't have those. Oh wait, no, we don't hit endpoints. Never mind. Sorry.
So I'm going to take the second derivative of that function.
No.
That sounds like a.
Wait, that's
Wait,
not
of
that
what
hard.
function?
So
The original. So the second derivative. So I'm going to take the next derivative of this. Okay, so I know right now that something, either a max or a min, is here. Okay? I don't want to lose this piece of information. Okay, so I'm going to circle it just so I don't lose it. I'm going to find the second derivative. Okay? Then we're going to evaluate it. I think we wrote this yesterday somewhere. Let me go back and see.
Probably. Excuse me, sorry.
If not, it's in the stuff that I didn't give. I didn't give you.
Oh,
That's
that's honestly kinda unfortunate.
I know I talked about the second derivative test yesterday. When did we do that?
I don't know, but I remember you saying we would have to use second
Did
derivative.
we?
I don't know if you
Was
wrote
it
it down.
Was it her just saying that we would have to use second
I think you
derivative and
just
then we
said
didn't?
it.
Did I just say it? Okay.
I think you just said.
Oh,
we
there,
would-
wait,
no,
that
I
was
saw.
the second
Wait,
derivative.
wait, I
Go
saw
back
it.
down. I saw a second derivative. Y double prime.
Yeah, I saw it. It's kind of high.
What are you trying to write there?
Right there.
Is that not?
Can
don't think
continue
that
up to
is
YW prime.
But yeah, I don't
Well,
know
okay,
what
this
that
will
is.
tell us if it's
Oh.
concave up or down, which will then in turn tell us if
We
it's
tried.
a min or a max,
Oh.
which is basically
tried.
what we're doing. But that, yeah.
I don't remember nothing.
Yeah, we attempted.
So-
But I think, hold on, I'm gonna look. It might not honestly be in these notes because it usually doesn't come till later. You can change it. I don't.
Sure am.
Change what? Change what?
There was-
Oh, is it hot? Josh, do not say it. Ew, there's hair in my water bottle.
Okay, it's gonna be this part right here, but
My
we're
phone.
using the second derivative test to figure this out. If, like, basically if f of x is, it's a modification of this, but is less than or equal to f of c, or if it's greater than or equal to. So if it's less than or equal to the equation at the point, then it's going to be a max. If it's greater than, it's going to be a min. So anyways.
So if it's less than the one we got, then it's
So if it's less than the value that we got, yeah, it's going to be. Okay, so second derivative.
Right.
So I need to take the derivative of this. What am I dealing with?
The giant
And
Product
rule.
We're so good at singing, man. We should join choir.
Yeah, we should.
Did y'all drop
Oh.
it?
No.
Oh, I was
No.
like,
I also
That's
forgot
not
we were
fun.
doing this. Let's see. Product rule.
I mean, you can start by writing it down, Josh.
what's the derivative of the first part?
We already found that.
No, what's the derivative
first
of
part
the
of the
first part?
Oh.
It's
What-
-2.
-2. Okay, making progress. Times the second part plus
-2x times
Can you stop talking weird?
times the derivative of the second part.
Whoa.
So
Whoa.
what?
You're like, your speech is slurred. Are you okay?
So it's e to the negative x squared times -2x. So it's just the first part.
correct. That's why I was waiting for you to recognize. All right, so we've got -2 e to the negative x squared plus 4x squared e to the negative x squared. So if we evaluate this at 0,
I could not tell you.
so if I plug in 0 for x, what happens here?
Oh, it's gone. Wait.
No, it's not.
It's -2.
It's -2. What happens if I plug in 0 for x over here?
That's gone.
It's gone, so I get -2, which is less than or equal to 1.
One.
So
that's the
therefore,
Man.
it is a max.
Wait.
What?
No, the 1 is max, right?
The one is the max.
Or
Is
the
that what
neg-
you're saying? Or
I'm saying that the value that we found
is the max.
is the max.
So one.
It's a max because of that.
-2 is
Not negative
No,
2 is the
yeah.
max.
Oh.
yeah.
negative
Wait,
two, not the max.
This is a different version, but it's this. We're using a second derivative test to figure this out. But f of x is less than or equal to, it's the second derivative is less than or equal to the value, then it's a max. If it's greater than or equal to, it's a min.
Zero. Zero is
Oh, 'cause 0 squared.
So that means,
Five.
therefore it's a max. So we officially have a max. Help if I
Wait, so
can
what
remember.
value is the max? Is it?
That's what I'm getting ready to write.
Oh.
We have a max value of 1 at x equals 0.
But we don't have a min.
Right.
Do we need to find that?
There's not one.
Oh.
And the whole reason we had to do that was because we didn't have another value.
Oh. So if we had another value, we would have both of them better than that?
Yes.
Are we gonna do a problem with both of them?
Do we need to continue minutes to do?
Possibly. Sure. We're gonna do one more problem and then we're gonna we're gonna be out of time, but we're gonna stop for the day and then we'll be
I'll wait.
okay. We might have to do some more notes to do what we're doing tomorrow, but I need to look at that a little more before. But we're not gonna be able to get through it today anyways. All right, 18. So same thing, just another problem with this. F of x is equal to x to the 3/5. -2 is less than x is less than or equal to 3.
Oh no, not a fraction.
So,
All right, so first thing I need to do, okay, now notice that it's a -2 not included and a 3 that's included. So what does that mean about my endpoints?
1 point.
you only have
I only technically have one.
Is it 1.9?
Okay. So
Is it
the derivative of x to the 3/5 is
3/5 x to -2.
now if we set that equal to 0, what is the only way that that's equal to 0?
X is 0.
If x is 0. Now, we need to go back and look at the instructions. It says, identify any critical points that are not stationary points. Okay? Stationary points, we said, are what?
Everything that the critical points are without this derivative.
So if it is a 0, it's a stationary point. Okay, so we're still going to use this to help us find what we're looking for, but we can't identify that as an actual point because it told us not to.
Because it said no.
It said don't do it. Okay, so the critical point is at 0, so f of 0, which is 0. I need to check something on that. Anyways, okay. Endpoint I don't even need to check the -2 because it's just less than, so it can't actually be like a max or a min. So I'm just going to check f of 3. So what is that?
It's 3 to the 3/5.
Which we could also write as the 5th root of 27.
Sure. Right. What you wanna do?
How do you rewrite that as the 5th root of 27?
'Cause we cubed 3 and then we take the 5th root of it.
Imagine if we take the 5th derivative of something.
Alright, so they're saying that this is not a stationary point, and I'm not sure why, so I need to figure that out. But this is going to tell us that this is going to be a
Stationary.
Max.
max because it's bigger than that. So even if they're saying we don't include that, we still know that this is a max because it's bigger than that value. So we're going to have a max value of, you can write it either way. They'll leave it as 3 to the 3/5 at x equals 3. And then they say that 0, 0 is not a stationary point.
For 14.
I wonder
Since-
if they mean that. What?
Since for 14, since that was x equals 0, 2, but that's a critical point.
That was
Is
because
it because it equals
that
1?
made it 0.
It's a so it's a stationary point because it made it 0. Or
I think something is written backwards. I need to check on that.
Okay.
Because this is the answer that's in the book. I'm not sure why this one. Or wait. Ethan, you can go if you want to. I'm just trying to figure something out.
Oh, he's looking for Nathan